This session will be recorded, and as we've already said, the recording and slides will be available afterwards. If we could all keep our microphones off unless we're speaking, that would be great. And we would love to see comments and questions in the chat. So let's try and make it as interactive as we can. Go to the next slide. So for the agenda today, we've got a pretty packed agenda. So we'll see how we do for time, try and move things on a little bit. After my introduction, we've also got a communications update from Amy at GemServe. Roger will be giving us an update from National Gas. And then we're really pleased to have three external speakers who are all members of this consortium to give us some respective updates and initiatives that they're carrying out. We've also got a breakout session in the middle. So again, on that theme of collaboration, we're really keen that these aren't just webinars and that there is kind of some interaction and we're kind of aware of who else is on the call and how we can help support each other. So yeah, please do get involved with that, and we'll talk about that kind of when we get to it. So yeah, we'd just like to welcome some new members of the consortium. So this is kind of how we're looking today. So yeah, a big welcome to Carlton Power, who are one of the hydrogen producers. Also a big welcome to Avara Foods. So they are a new potential off-taker, so exploring hydrogen for their many sites across the West Midlands. And then we've also got Hydrogen East, who are joining us, and they're an organisation exploring hydrogen across the east of England. So it'd be great to kind of identify cross-region opportunities with them. So I thought it'd be worthwhile to start today by just setting the scene, because there's been quite a lot of updates for those who have been following in the hydrogen world over the last few months. So if we go to the next slide. If we just hone in on a few of these, I think there's too many updates to kind of run through, but really high level. In April, we had the HAR2 projects shortlisted. So this is the second hydrogen allocation round, which awards funding for electrolytic green hydrogen production projects. There was 27 projects shortlisted across England, Scotland and Wales. And it was really great to see that 3 of those are in the West Midlands specifically. And 2 of those are by Carlton Power, and Eric will be taking us through those a little bit later. Early this month, we also had the comprehensive spending review. So this saw £500 million of funding committed to the UK's first regional hydrogen transport and storage network. That's a really big step forward for getting hydrogen to industry that needs it. We also saw commitment to CCUS projects, including the Viking and Acorn clusters, which again are really imperative for the wider hydrogen projects that they're involved with. And then just this week, we saw the industrial strategy launch from government. So this laid out 8 kind of key future growth industries, of which one was clean energy, and hydrogen plays quite a big part within that clean energy plan. So this saw commitment for the continuation of those hydrogen allocation rounds. So we'll see a HAR3 next year and a HAR4 from 2028. It also confirmed that the first hydrogen transport and storage business models will launch next year, as well as a hydrogen to power business model will similarly follow. And we're hoping to get a bit more meat on the bones with all of these as far as timings and whatnot later this year in a revised hydrogen strategy. To the next slide. Just some other key points from that strategy. The government has also committed to consulting on extending the clean industry bonus to hydrogen projects. So that will unlock some further funding for hydrogen projects, as well as removing the climate change levy on electricity produced for electrolysis from next year as well. So again, that's going to really help to drive down the cost of electrolytically produced hydrogen. Finally, they've made the point that they will continue assessing the case for hydrogen blending into the existing gas distribution and transmission networks, and the transmission blending will be consulted on this summer. So some really big updates, and I think it really demonstrates that this is all moving forward. So I've called this the Cadent update. It's kind of more of a Hydrogen Valley update, I guess, but really just bringing it all back to the Hydrogen Valley. So we go to the next slide. This is the map that we've kind of shown for some time now. So we've defined the Hydrogen Valley area, and we've demonstrated that there is the potential for a project union pipeline to bring hydrogen from Bacton or from the South Wales cluster kind of to industry across the Midlands. But I think we're really keen now is to start digging down into the detail that kind of sits under this and understand where exactly the demand for hydrogen sits across the Hydrogen Valley area. So if you go to the next slide, I've been doing some work recently to do just that. So I focused on the West Midlands view for today, but clearly the demand picture across the entire Hydrogen Valley area is important. But if I just summarise some of the findings from that, first of all, we've demonstrated that there are over 100 industrial sites that are considering the use of hydrogen as a fuel to decarbonise across the West Midlands. So clearly the appetite is there. It's also great to see that this represents a really wide range of sectors, so including ceramics, automotive, metal, paper, food and drink. That's just naming a few, but I think again that really helps to challenge some of the assumptions that it isn't just heavy industry that is looking for hydrogen. And I've also put here we can start to see the emergence of some distinct clusters. So I don't think it'll come as any surprise. It largely follows the urban centres within the West Midlands, but we can see some really strong demand in and around Birmingham, Wolverhampton, Stoke up to the north. And so where this is all going is thinking, how can we supply that demand? So I've put the Project Union pipeline that kind of just comes down across the south of that area. And it's quite easy to see how that could link in and meet that those demand hotspots. Similarly, you can see just about on the right-hand side of the map there, some blue lines. That represents the south phase of the East Coast Hydrogen Project. And again, you can note it's really not that far away, the outer proximity of that pipeline to the West Midlands. So you could also see how that could feed in from the east. And then up towards Stoke, you've got the hydrogen storage, so the salt caverns that are proposed. I think literally 20 kilometres or so just out of the frame, as well as the HyNet project. So again, can really see how this can all come together. Where this is all going, I think this will lend itself to doing some feasibility work for where exact pipeline routings might be best placed, and also really starting to work more closely with producers to understand how we can get production in region to meet some of this demand as well. So that is it in a nutshell. And I will now hand over to Amy, I think, who will give us a quick update on communications. So thanks very much.
Hi everyone, I'm Amy. I'm part of the comms team at GemServe, and I support the marketing and comms work for the Hydrogen Valley. So next slide, please. I'm just going to provide a quick update on the marketing front. So one of our main focuses has been continuing to build out our website with fresh content. So we've updated this to include our new members. And we've also written some fresh blog content talking about the Midlands' potential as a hydrogen hub and tackling misconceptions around hydrogen. We've also launched the Hydrogen Valley LinkedIn page back in October, which has been steadily growing. So as you can see there, it's grown by 111% since our last consortium meeting, which is really great. And we've had some really strong engagement rates on our post as well. It's a really great place to get regular updates about the programme. So we post key information, announcements and updates on Hydrogen Valley And we also do spotlight posts on our members and the industries involved in the programme. So if you do have any updates or any news you'd like us to share, please do get in touch and we can shout about it on LinkedIn. We're now approaching 500 followers, which is fab. So please do give it a follow if you haven't already. And I'll drop a link to that in the chat in a moment. We're also currently running a campaign based on the member case study survey that we sent out recently. So thank you to everyone that's already completed it. If you haven't yet, we'll be sending out some reminders to do so, but it'd be really great if you could just take a few minutes to fill it in. And I'll also pop a link to the form in the chat. So the responses that we collect from the survey are going to be used to build out our upcoming blog, and we're also using them to create case studies, which we'll then be publishing online and on LinkedIn. So it's a really great way to showcase your role in the programme. And you can see an example of one of our case study posts there with Birmingham Airport.
We might need a little bit more time next time. I'm not sure how the other rooms were, but we were mid-flow.
Ordinarily, when I say return to room, it gives you 60-second warning, but it seems to have moved everyone back immediately. So apologies for that, but thank you everyone for getting involved. Sounded like there was some really good discussions going on there that I very rudely cut off mid-sentence. But I don't know, because we've got some extra time, I wondered, if there's anything that anyone wants to feed back on, anything interesting that was discussed in the meetings. It'd be good to hear some feedback on that.
I think the only feedback I can give is just increase the timing of the breakout rooms. Really, there was some really interesting conversation going on with the participants there, and because we lost that communication now, I don't know if we can reach out to them. I think it was Jim and James. So maybe perhaps like an email for all the participants who we can reach out to, really.
Yeah, definitely. I think we'll be sending out forms anyway afterwards. So if there's anyone you'd like to get in contact with, please let us know. As you probably appreciate, we can't just send everyone's emails just for GDPR purposes. But yeah,
Sure.
no, yeah, definitely. Would love to encourage the continuation of those conversations. So yeah, please do get into contact with us if you'd like to get in touch with anyone else on the meeting.
Cool.
Do we still have time, Michael, to further discussion, or do we need to move on?
Yeah, sure. We're actually running 4 minutes early, so yeah. If
Longer in the rooms.
Yeah.
Great. I think I'll just pick up on one element then, and that was around heat networks, because that is an area that I think could be really interesting for future collaboration. Strikes me as kind of project where you can have multiple different energy productions. So whether that be through heat pumps and CHPs and whatnot, but also as and when needed, potentially hydrogen could come into that mix as well. And again, that could benefit more than just industry, but as well kind of local housing developments or commercial premises, hospitals, universities, and the like as well. So that's something I would definitely like to explore a little bit more. I'm not sure anyone's got any other thoughts on that. If I open it up a little bit. Yeah, it's a good point. Waste heat as well. Barry, got your hand up.
Yeah, by the time we'd finished all the introductions, our time was over, to be honest. But I was just raising the point that we're putting an awful lot of energy and funding into top-down initiatives, what I would call top-down initiatives, building the pipelines, etc., etc. We're not putting anything like enough funding or effort into finding the end users, the people who can actually take this hydrogen vector and use it. And I know we said at the beginning of the show here that there was 100 odd users that we were looking at. One of the things we do is we go into various industries and we do a deep decarbonisation survey, and so we give end users an 80 to 90% confidence that hydrogen is the vector for them. And then they've got the confidence to actually talk to Cadent and other people to say that, look, we're interested in this stuff. But until these end users know for sure that they can actually use hydrogen in their processes, then they will just stay interested, if you know what I mean. They won't go beyond interested. They can't go beyond interested because you can't make a business decision on, changing your entire energy vector over from natural gas to hydrogen if you don't know how you're going to control it, how you're going to burn it, will it affect your process, etc., etc., etc. So we need to do that work as well. We need to do an awful lot more bottom up to try and meet the top down.
No, absolutely. I think some really valid points there, and I think as we'll see from some of our speakers today, I think that's where a lot of industrial trials also come into their own, as you say, to kind of demonstrate that hydrogen is viable in those processes. So yeah, no, absolutely agree. Okay, I'm glad that was useful, and we will definitely take the feedback and increase the time for the next session. But I think we'll move on for just now then. And I'd like to hand over to Roger, who'll give us an update from National Gas.
Yeah, hi everyone. I'm Roger Barnfield, Senior Hydrogen Development Engineer at National Gas. So been with the team for about 2 years now. I'm just going to give you a bit of an overview on and an update on Project Union. Go to the next slide, please. Oh, next one. So I think I'll just briefly touch on this. So I think just for the purposes of any new members in the room, just a brief update on kind of what we do as National Gas. So we own and operate the high pressure transmission network in the UK. We have approximately 7,600 kilometers of pipeline, run up to 94 bar. We supply a range of users, so power generation, domestic, industrial, and commercial. And we transport approximately 3 times the amount of energy through the gas network as goes through the electricity network. So huge volumes of bringing gas onshore, distributing around the country so that businesses can use it for their processes. If you go to the next slide, please. So our interest in hydrogen is that we're looking at building Project Union. So Project Union is a hydrogen backbone that aims to span the whole of the UK. So we're looking initially at approximately 2,500 kilometres. So it's going to be about a third of the size of the existing natural gas network. And what we're looking at doing is connecting strategic locations of supply, demand and storage. So primarily we're targeting the industrial clusters so we can connect the largest and most developed users together. But I think the real kind of key part of Project Uni is that we're going to be connecting to storage. So while in the kind of early stages of the hydrogen network where supply and demand may not balance completely, we've got that kind of certainty of supply so that we can make sure that users get the power they need to run their processes. Our approach is that we are looking at using new and existing infrastructure. So a key part of Project Union is that we're looking at repurposed pipelines. So we're looking at pipelines on the natural gas network that we potentially could transition to hydrogen. So there's obviously a technical challenge there about how we do that, which me and my team are working on at the moment. But clearly there are significant benefits from that. So there's obviously time, cost, environmental impact. So if we can meet that challenge, then we can start developing this hydrogen network a lot quicker and roll it out a lot sooner at a lower cost to the end user. So go to the next slide, please. So a little bit more of a kind of breakdown on Project Union, a little bit more on the phasing strategy. So we break Project Union up into 9 regional sections, broadly aligned to the industrial clusters that we've identified. So although we've got numbers to these, I think the phasing is still a little bit fluid, because obviously the hydrogen is developing at different rates in different areas. So this is kind of our initial view as to what it will look like. But I think what we are clear on is that East Coast, that's already been mentioned, is going to be going first. And that's really key because that's one of the few locations in the UK that has access to storage. And obviously, once we then build out from East Coast, every area after that will also then be connected by default to that storage. So they will get them benefits when the build out carries on. I think the other kind of reason for East Coast as well is that it's located quite centrally, so it gives kind of options to build out north up to Scotland to get some of them green renewables, west towards projects such as HyNet, and then obviously south down towards the Hydrogen Valley region. So it's a really good kind of starting place to expand from. Let's get to the next slide, please. So again, kind of mentioning East Coast again, and kind of the reason for this is that we had a final determination from Ofgem last week that provided us with funding for approximately £40 million. So that will enable us to progress with the feed stage of the East Coast. And for us, that's obviously great news. That means that we can now progress our plans in the East Coast region. We can start doing them kind of like next stage of studies to start thinking about how we actually develop this and how we actually start building this. So in terms of the hydrogen economy as a whole, this is a really positive signal that actually Ofgem agreed that there is a need for this network, and they've put some funding behind it so that we can make progress and we can start moving our plans forward. I think the other kind of, I suppose, to give a bit of an update as to where we are with the other section. So we've also submitted reopeners for the north section, which goes from Teesside up to St Fergus, and for the northwest section, which goes west across to projects such as HyNet. We've not put reopeners in for any of the other sections yet because Ofgem have basically said they're not going to accept any more reopener submissions at the moment. So what we need to do, we need to wait until the HTBM process kicks off before we can submit any kind of further plans. So I think, as Aaron mentioned at the start, that looks to be around the 2026 timescale. So we are looking at progressing that as soon as possible, and we are talking closely with government to try and move that forward as quickly as possible and get some certainty as to what that process looks like, so we can start progressing the subsequent sections that will connect effectively alongside and connect into East Coast. So I think that was kind of the key update I wanted to provide, really. It was just around getting the funding for East Coast. Like I say, it's obviously a really positive signal for us. It means that we can progress, and then it kind of, hopefully that will be a signal to industry that these plans are actually moving forward. We're going to be making progress, and that's a signal to everyone who's kind of been on the fence that actually it is going to happen, and people will get on board and start putting a bit more thought into their plans and how we can kind of connect everyone to this network going forward. I think one more thing that I was going to mention, actually, I don't have a slide of any timelines on, but I think just to give you a little bit of a flavour as to what it's looking like at the moment. So East Coast, we're expecting to be approximately a 24-month feed process. So we're looking at, now we've got the funding for that, kicking that off imminently with a plan to get it delivered by around summer 2027. That then would then be subject to another HTBM bid to get funding for construction. But if everything kind of goes to plan, we'd be looking at getting that operational around the 2032 timescale. Obviously, the subsequent sections, so north, west, and south towards the Hydrogen Valley region, would follow that. So we are working on what the timeline looks like at the moment, but probably put a bit of a finger in the air. We're looking at probably around the middle of the 2030s as to when we feel like we may be able to start developing them pipelines and get them operational. So I think that covers the slides I wanted to go for. I think there's another one with our contact details, and so obviously willing to take any questions, or if you've got any kind of thoughts after the meeting, please get in contact. We're obviously keen to hear, and anything that we can take on board and shape our plans will help us ultimately.
Thanks very much, Roger. I think Mark, you've got a hand up.
Yeah, it's just a quick one, really, just about the whole supply and demand thing. So in terms of your timescales, how is that feeding back into the potential off-taker community in terms of giving them assurance, timescales, etc., for their own business planning, business investment decisions, and all that kind of good stuff?
So in terms of giving timescales, I feel like now we've got the funding decision for East Coast, we've got progress there, and we've got a little bit of a better idea as to what that timeline looks like. I feel for the subsequent sections where we need to go through this HTBM process, there is a bit of a question mark, because at the moment it's been stated that it's going to be 2026, but we don't know if that's going to be start of 26, end of 26. So there is that kind of level of uncertainty at the moment. That's kind of what we're quoting mid 2030s. We don't know if it's going to be 2034, 2035, for example. So I feel like all we can do at this stage is keep talking to government, keep trying to get an understanding as to what that process looks like, when it's going to open, and then we can feed that data into our plan and hopefully get a bit of a more accurate date as to when we're actually going to start doing the feed and doing the construction of some of these later phases.
Great, thanks.
Okay, if there's no other questions, then thank you very much, Roger. We will now pass over to Mike from Progressive Energy.
Afternoon, everyone. Thanks for the invitation to share some of what we've been doing across our projects. Grab the next slide, please. So I work for Progressive Energy. We're a low carbon energy project development company formed around 25 years ago, with a focus on decarbonising industry and power. Focus currently is on low carbon hydrogen, on carbon capture and storage. We've also worked across the renewable space as well, and we've originated and led on multiple decarbonisation projects. HyNet, which I'll talk a little bit more about, is the most advanced of these. So we tend to partner with others to allow us to deliver decarbonisation at a meaningful scale. So on the right there, we've got some of the programs that we've been involved with. ET is the entity that's going to operate a large-scale low-carbon hydrogen production plant within the HyNet area. Peak Cluster is a carbon capture cluster that we're developing in the Peak District to decarbonise the cement industry there. And Granian is our green hydrogen production business. Next slide. So many of you, I think, will be familiar with HyNet, and HyNet is our project which is aiming to be the first large-scale clean hydrogen production and use cluster. There are various elements that need to come together for that to happen. So on this map, you can see the orange line, which is a carbon dioxide transport and storage pipeline up to the East Irish Sea. That's being led by ENI, and we had the final investment decision on that in the last couple of months. That enables capture from industry, including energy from waste. So we're then capturing carbon from biomass, getting access to negative emissions. Cadent is looking after the hydrogen distribution pipeline. So once we've produced hydrogen, we will be able to transport it to users. And a key part of this is the large-scale production of clean hydrogen, initially from natural gas with carbon capture. That's being developed by EET. A key part, as has already been mentioned on the call is that once we have a low carbon hydrogen that we're producing, that's only worthwhile if we have people who are ready to use it. So mostly today I'll be talking about our work with potential users. Next slide, please. In fact, let's skip on to the next one. Yeah, so since 2019, we've been working on industrial fuel switching competitions with government, initially with BEIS, now with its successor, the Department for Energy Security and Net Zero. These are competitions run by government that provide funding to work with industry to demonstrate hydrogen in their processes, with the intent of getting them to the point where once hydrogen is available to them, they're ready to commit to using it. So we've done demonstration projects with Pilkington's float glass industry, with Kellanova, who make Kellogg's Foods, with Unilever, and with Novelis in the metal industry as well, and feasibility studies with others in the food industry, the paper industry. We've also done CHP work, so on development of a combined heat and power plant at SR. Next slide, please. So when we go to a site, as I say, our aim is to bring them to the point where they're able to commit to using hydrogen once it's available. So there are a range of concerns that users typically have, some of them technical, some of them commercial. So the first one being product quality. Is the product that's seen by the consumer going to be affected by the use of hydrogen? Regulatory compliance, are we going to be able to operate within our existing permits? Will we be able to hit our NOx limits? Will we be able to do it safely? Will our equipment last? And then kind of commercial concerns around what's it going to cost us to convert? Security of supply, so what do we do if hydrogen's not available one day? All of those questions we address by the IFS program. And then there are other commercial concerns, including so low carbon credentials. Obviously, sites are only going to make switch to hydrogen if it's cleaner than using natural gas. So that's handled by the government's low carbon hydrogen standard, which essentially ensures that hydrogen production is only supported by government if it meets their emissions threshold of 20 grams per megajoule. And then the kind of cost and efficiency aspects that the sites are interested in. And then on the fuel cost side of things, the LCHA, the low carbon hydrogen agreement, essentially ensures that users will receive hydrogen at natural gas costs. And then in the IFS program, we look at efficiency of operation. Please. Yeah, so technical feasibility, we ran feasibility studies at all of these sites to review the evidence base and assess whether there were any outstanding questions. And following that, we designed demonstrations to validate feasibility work, to address any residual concerns, to gather operational data on efficiency of operation, on NOx, on product quality, and to develop commercial operating methodologies so that once hydrogen is available, we're ready to go. Next slide, please. So the first demonstration we did was on a float glass furnace. This is the Pilkington St Helens furnace, which uses about 50 megawatts of natural gas that's fired across molten glass in alternate directions. And the heat from the flames radiates straight into the raw materials, but also into the furnace structure. So in terms of the technical feasibility, Pilkingtons were concerned about heat transfer from the flame into the melt. They were concerned about NOx emissions. They were concerned about impacts on their refractory. And we primarily addressed this at feasibility stage through modelling. So Pilkingtons developed new luminosity modelling and a new model for NOx emissions as well. We ran hydrogen into the furnace through one of their ports, went up to 100%. So the picture in the middle there is a port that is firing 100% hydrogen. As you can see, the flame is not very visible there. But we did that over the course of about 3 weeks. Produced glass that was sold to Pilkington's existing customers, and the trial was really successful at validating the modelling that Pilkington's had done, showing that they maintained their efficiency of operation, and that hydrogen was a suitable fuel once it's available from HyNet. And Pilkington has gone on from that and entered the HAR process, the hydrogen allocation round process. So based on the results of this testing, they are now working to install an electrolyzer that allows them to put hydrogen into their furnace for real. Next one, please. The next demonstration we did was at Unilever's Port Sunlight facility. So this is a package boiler. So we converted a natural gas boiler to a dual fuel natural gas hydrogen boiler by changing the burner. We were able to show that we could meet the site steam load reliably over several weeks. So that meant that for something like 8 hours a day for 4 weeks, all of the site steam demand that was used in making the Unilever products was ultimately derived from hydrogen, and we were able to evidence flexibility between hydrogen and natural gas. We're able to operate within the existing NOx limits. We're able to modulate the burner effectively. We're able to operate at comparable efficiency. But it being a package boiler, the results of that are kind of widely applicable to package boilers across the UK. One, please. And then we go on to a feed study that we did with SR on a hydrogen combined heat and power station to supply the refinery. That study gave us a really good view of equipment availability and costs, and is being taken forward now by EET Hydrogen Power to make that plant a reality. Next one, please. And then the next one is the metals industry. So this is a trial that we completed in February this year. So we've converted an aluminium recycling furnace at Novelis from a natural gas furnace to a dual fuel natural gas hydrogen furnace. And over the course of 2 weeks, we worked our way up from the 0 to 100% hydrogen. And by the end of week 1, we were melting out aluminium entirely based on hydrogen heat. Melted hundreds of tons over the course of the trial and maintained the product quality. So again, Novelis now has the evidence base to use hydrogen once it's available from HyNet. Next one, please. And then the final industrial trial that we've done was with Kellanova. So we executed a program in their Centre of Excellence, their R&D centre, where we were able to demonstrate on a production oven that you could produce their full kind of suite of core products using hydrogen, so Rice Krispies, cornflakes, brown flakes, Special K. We had a side-by-side comparison with natural gas. You can see there's on the left, you've got Rice Krispies made with natural gas. On the right, you've got Rice Krispies made with hydrogen. And we're able to show that on hydrogen, we could meet all of the Kellanova quality standards. And that, again, once it's available at scale, hydrogen is a suitable fuel for decarbonising Kellanova's operations. Next one, please. Yeah, so kind of looking back at the trials and what we've learned from them, there are kind of conclusions specific to those industries about hydrogen suitability. And we can conclude that it's a suitable replacement for natural gas in all of the applications that we've investigated to date. We deliberately designed those trials to be applicable more widely than just those particular sites that we were working on. We were able to execute those trials using existing engineering design practices and standards. There are sites that are very kind of comfortable thinking about and working with hydrogen. There are sites where that's more of a challenge, but we found that external expertise is available to assist site teams that aren't familiar with with hydrogen, so that doesn't need to be a barrier. Next one, please. Yeah, so that's hopefully giving you an insight to some of the work we've done and our efforts to develop the evidence base for use of using hydrogen once it's available. And yeah, really keen to talk to anybody considering hydrogen and kind of work with you on demonstrating feasibility in your particular processes.
Thanks very much, Mike. Really, really interesting. If I can ask a quick question, we'll also open up if anyone else has a question. We've got a minute or two. Obviously, yeah, so we're able to demonstrate that hydrogen worked in those particular industries. I know you said at the very end there that the hope would be that could be used more widely. Are we seeing that is the case? So, you know, for example, the aluminium at Novelis or other aluminium processors able to take that kind of directly and go, okay, yeah, we have the confidence now, or generally is it your understanding that they would want to do their own further trials, etc.?
I think the work that we've done provides a lot of confidence. I think Novelis specifically have a lot of plants worldwide, so they're able to take that learning and deploy it. I think we did the work in February, so we're a little bit too early to say whether the metals industry as a whole has taken hold of this and started to develop projects on the back of it. I think that there is a European research program looking at a lot of the aspects that are relevant to the metals industry as well. I think maybe a better example would be the package boiler work at Unilever. There are a lot of companies offering hydrogen-ready boilers and hydrogen burners, and yeah, we're able to point to Unilever as a site where it's worked. And I think that does give users a lot of confidence.
That's great. Thank you very much. Got time for maybe one more question if anyone's got any. If not, then yeah, thank you very much, Mike.
Thank you.
With that, we'll now hand over to Andrew from Ceramics UK.
Thanks, Aaron. Thank you. Okay, so jump on to the next slide then, please. So yeah, contact details. They're happy for the slides to be shared around the group. So if you can knock me on another one, please. Okay, so just to set the scene, then quick overview of the UK ceramics sector, our emissions, and hydrogen's reduction potential across the ceramics sector. Then talk about our industrial fuel switching project. Mike's just been talking about various IFS projects. We've also been progressing an IFS project over 2 phases. So I'll count what's been happening across those two phases, and then wrap up with a few conclusions and a quick Q&A at the end. So if you want to skip me on one, please. So just a few facts and figures about the sector. So about 20,000 full-time direct employees, annual sales across the sector about £2 billion, of which about 600 million are export sales. I think the key metrics to be aware of is we've got about 90 member companies and about 150 ceramic manufacturing sites scattered all over the country, and very few of those are in locations near the large industrial clusters. We're very much in those dispersed locations. So it's a key thing for the hydrogen discussion. If you can just knock me on another slide, please. Just from a energy and emissions perspective, a few more facts and figures. Then we're an energy intensive sector. We fire our products to certainly as a minimum 900 degrees, more like 1,000, 1,200 degrees, with one of our members firing all the way up to 2,750 degrees. So phenomenally hot temperature. So we're energy intensive with energy and climate costs typically making up about half of total production costs. So had we done this sort of event a few years ago, it would have been more like 35%, but with the energy price rises, and that's such a big footprint in our costs, then that's risen to more like 50%. So we're gas intensive, about 4.5 terawatt hours per year across our members. It's about 85% of our energy mix, and the bulk of the rest of the energy use is electricity, but that's very much smaller than our gas use. Okay, if you want to just knock me on another one. Just in terms of applications, I mean, some of the applications you'd be familiar with, tableware, giftware, these sorts of products we're all familiar with, but other applications less so. Your mobile phone has got about 200 electroceramic components in there, critical components within cars and aerospace. Energy touches pretty much every energy generation technology, be it conventional energy generation. It keeps the heat in any high temperature processes, but also renewable technologies as well. So as I like to say, ceramics are used in lots of different applications, often hidden in plain sight. So everything from toilets to turbines to teeth. It really is quite a diverse sector. Okay, if you knock me on another one. So in terms of our emissions across the sector, about 1.25 million tonnes. Our Scope 1, Scope 2 emissions, the bulk of those are direct emissions, with the majority being fuel combustion emissions, plus then some process emissions as well, and the minority being indirect emissions from electricity use. A couple of years ago, we engaged with our members and then looked at, we updated our 2050 roadmap and cast our views forward in terms of what the decarbonisation technologies might be between now and 2050. So they've all got a role, be it electrification, be it carbon capture, but hydrogen was seen as a very significant technology across the ceramic sector, accountable for the biggest chunk in isolation, a 36% reduction. So totting the numbers together, that could give us CO2 savings of about 450,000 tonnes per year across the sector. Okay, next slide, please. So in terms of the projects, we've done so industrial fuel switching projects, been 2 phases. Phase 1 was very much a quick and dirty study. We did this in 2022, £300,000 BASE funded project, 6-month duration. We worked with 12 of our member companies, and really the objectives there were to do a bit of a literature survey in terms of what's happening globally in terms of firing ceramics with hydrogen, and there was little bits happening, but not a lot of work back then. We wanted to demonstrate the firing of a range of ceramics with 100% hydrogen using a modified kiln that the glass sector had developed. So they developed a pilot kiln. We wanted to modify that and use that to fire some ceramics in it. So we did that. We also wanted to design a custom pilot kiln to look at that in much more detail and to start thinking about phase 2 to look at retrofitting some production scale kilns. So they ran for a period of time instead of on methane, on hydrogen instead. And we also took a techno-economic model that the glass sector had developed, and we applied that without making any changes to it to the ceramic sector. So if you knock me on another slide, please. So in terms of those firing trials, the picture there on the left-hand side is the pilot kiln that the glass sector developed. The pins or the tubes you can see at the bottom that allowed water to flow in and out of the kiln, and that was to simulate a float glass load. So what we wanted to do is to basically rip all that bit out and to put some ceramics in that kiln instead. So we had a cavity that we could fire ceramics in. We also needed to change the burners to ones which you'd find in the ceramic sector, that glass kiln was electrically heated up to 1,000 degrees, and then other fuels did the heating above that. We want to study what happens when you take it from ambient temperature up to firing temperature just on hydrogen. So we looked at 3 different types of ceramic bodies. We had heavy clay construction materials, so bricks, clay roof tiles, clay drainage pipes. There's even a flower pot in there at the back of the kiln. That was the first body. The second one was whiteware, so tableware, giftware, sinks, plates, tiles, those sorts of things. And then refractories was the third one. And we looked at 2 things. We fired in hydrogen and we fired in methane, compared the 2. And there you can see our former Prime Minister in a brief tenure as PM, looking at a couple of bricks, one methane fired, one hydrogen fired. And of course, there was no difference in the quality of the product. So those firings, world first, demonstrated that various ceramics could be fired with 100% hydrogen without impacting product quality. Next slide, please. Also looked at the techno-economic model that showed that hydrogen could be cost effective by the 2030s and cost optimal by the 2040s. There's also a few links on there for a bit more information about what we did in phase 1. Next slide, please. So phase 2, this was a DESNZ funded industrial fuel switching project, £6 million 2-year demonstration study. I wanted to take that work which we'd done in phase 1 and really expand that to demonstrate the technical and economic viability of hydrogen firing ceramics. And that covered 4 key work streams. So we wanted to develop a bespoke pilot kiln to study the firing of various ceramics under various conditions. We wanted to look at the engineering. So we wanted to retrofit some existing production scale kilns which run on methane currently to run on hydrogen. And we also wanted to pull apart that techno-economic model so that the assumptions and information was relevant to the ceramic sector, and it wasn't just taking something which was relevant for the glass sector, which didn't necessarily fit us, and then to share that information across the ceramic sector, other foundation sectors, both in the UK and further afield. So that was the outset of the project. So next slide, please. So we're now working with 13 of our member companies. The logos are on the screen, plus 4 external partners. Glass Futures, where we've got the pilot kiln, Otto Simon, our principal engineering contractor, Bock, who were supplying the hydrogen for the demonstrations, and ERM, who were doing the techno-economic modelling. Next slide, please. So 8 work packages for those 4 facets of the project. So work packages, work package 1 was about specifying that kiln, getting it built, getting it delivered, getting it commissioned. Work package 2 was then about using the pilot kiln. For the engineering side of the project, work packages 3, 4, and 5. These were the engineering production demonstrators that we hoped to do. We did set out to do 3 with an eye to doing 2. And that's where the project was for the bulk of its time. Unfortunately, both of those over recent months have fallen by the wayside, more for reasons outside of the project. So the 2 main demonstrators, one stopped in December and one stopped a couple of weeks ago in May. So unfortunately, that bit of the project's not progressing now. The other bits are. So techno-economic modelling, that continues, ditto dissemination. Okay, next slide, please. So just in terms of where we are now, with that pilot kiln, we've had it specified, we've had it built, we've got it delivered, installed, commissioned. It's running on methane and hydrogen and blends of the 2. The only thing we haven't done yet is to run it under reduction conditions, so that's in an atmosphere starved of oxygen, and we've deliberately held off that just in case there's any impact in terms of damage to the refractory. So we didn't want to damage the kiln which would then hobble us from doing the rest of the project. So we've kept that aspect to the end of the project, and a couple of weeks' time we'll be swinging on to that. So it's quite a big pilot kiln, 4 cubic meters, 2.2 tons capacity, which can run up to a peak temperature of 1500 degrees. So it gives us a good volume to work with and to prove various ceramics can be fired with hydrogen. So in terms of actually using the kiln, the 2 main work packages are one work package 2B. That's where we're taking 2 brick bodies, bricks supplied by Wienerberger, and we're looking at firing those 2 brick bodies under a wide range of conditions. So playing around with the peak temperature, going a bit hotter, going a bit colder, looking at the dwell times, basically cooking it for longer or shorter, playing with the fuel blends, playing with the firing atmospheres in terms of percentage of oxygen, and really moving the firing curve round and comparing what happens when we do it with methane, we do it with hydrogen, what differences do we get, to try and show that if there's any differences in terms of firing with hydrogen. Work package 2C flips that, and here we study a range of industrial ceramic products and fire those under the conditions set by the manufacturers. So you can see there, bottom left, we've got some sanitary ware, some sinks and toilets from Ideal Standard, which have been glazed and gloss fired. The glaze firing has been done in hydrogen. Okay, next slide, please. Technical results, basically it's boiling down to we're not seeing any technical differences in terms of the product performance. NOx has been mentioned because obviously firing with hydrogen, the NOx levels are a bit higher, so we've had an eye on where we fit with our emission limit value, our current emission limit values, and we're below that, even though the results for NOx are higher than with methane, as we'd expect. So we've been probing and looking at that, but really now we're at a point where the test results are starting to come back thick and fast. Okay, so next slide. So going back to those production demonstrators, so we did intend to do the 2 trials. The first one was at Warvin. There we were looking at a continuous kiln that's about 70 meters long, makes clay drainage pipes, and what we wanted to do there was to fire 2 of the zones on hydrogen. So looking at the peak temperature zone and one of the key warm-up zones, because if you can get it right at those 2 zones, you can get it right for the rest of the kiln. Those are the tricky ones to get right. So that was the intention. We completed the feed studies, the pipeline and instrumentation diagrams. We did the HAZOP study and the LOPA laser protection analysis. That was all completed. So the next stage literally was to put spades in the ground and start to build that. But there was a few changes happening on site at that point. So that meant we couldn't complete it in the time which we had available, which is a shame, because that particular project, what we found was we didn't need to completely change the burners. We could use the existing burners with a few slight modifications. So that was kind of one of the key bits of learning from that trial, was it was more about burner modifications rather than a complete burner change. Second demonstration was to look at a batch kiln making sanitary ware, Ideal Standard, and here the intention was to fire the kiln completely on hydrogen, no methane whatsoever, and to do that twice. Again, got it to the same stage, although we did find with this particular kiln that we would have needed 33 new burners to run the trial. We couldn't just modify the existing burners. It would have been a suite of new burners on that particular kiln. And again, we took it as far as next step would have been spades in the ground and start to build. So next slide, please. Just skip over this one. It's a techno-economic model. We've got 5 archetypes, which are basically models of different facets of the industry, and we're running that that model at the moment, generating results. That's been completed for us over the last couple of months, and we're very much in an active stage working with that techno-economic model. So if you just nick onto the pretty much the last slide. So what we've found, hydrogen firing could cut ceramic sector emissions by about 36%, 450,000 tonnes per year. Phase 1 of the project, we showed that hydrogen could be used to successfully fire a range of ceramics with 100% hydrogen with no loss in product quality. Phase 2, the different facets of the pilot kiln that's been commissioned, the trials are now well advanced. Early results are starting to filter through. We're seeing no real difference in terms of product performance, although we are seeing higher NOx levels as expected. On the production demonstrators, those retrofitting activities are not now proceeding, but we've gained a lot of information, a lot of key insights from those 2 detailed studies. So there's lots of learning which we can then share across that with our members. We're very much at the end of the project now, looking to complete the pilot kiln work end of next month, and then we're into the thick of writing everything up. So that's it. I don't know if we've got time, Aaron, for a few questions, or whether we'll come back at the end for those.
Yeah, many thanks, Andrew. We're a little bit tight. If there is any, we can put them in the chat maybe, and we can pick them up if we do have time at the end. I think that probably is the best. That's okay with you?
No problem. That's fine. Yeah, no worries.
Okay. Thank you very much. Okay. We'll now then hand over to Eric at Carlton Power.
Afternoon. Thanks for the opportunity to come talk to you. So yeah, interesting to hear the previous kind of presentations about some of the practical issues of using hydrogen. So I'm here to talk about a little bit of practical issues and kind of real case models around where we can produce said hydrogen for use in the system. So if you'd like to kind of go through to the next slide, please. So a bit of background on Carlton Power. We're a privately owned energy developer based in the UK. We've got a 30-year history in developing complex energy infrastructure projects. And through that development work, we've enabled about £1.5 billion worth of investment in UK energy infrastructure. In respect of hydrogen, we've formed a joint venture with Schroders Greencoat in order to develop a hydrogen production platform. And through that, we have secured 3 of the 11 projects in HAR1. So a third of all the HAR1 projects sit with Carlton Power. And then in HAR2, we had a further 2 projects which were shortlisted. And we're currently working through those to get to a point of being able to secure contracts. Very much when we've been looking at these projects, our focus has been on the large industrial gas users, across a number of different areas, because we felt that was somewhere where, firstly, the technical barrier was relatively low, and secondly, that you could have elements of dual fueling and fuel switching, which would ensure that the off-taker could maintain their energy security and therefore maintain their production capability, where you've got a fuel such as hydrogen, which is in turn reliant on renewable energy, which is invariably intermittent. We'll go to the next slide, please. So in terms of our portfolio, that's the projects. So the 3 in green, Barrow, Trafford and Langage, are the 3 HAR1 projects for which we have contracts in place with government, and they will be kind of carried forward to get into final investment decisions over the rest of this year, and then be providing first hydrogen throughout 2027. The 2 other projects, Walsall and Hartlebury, they are the 2 HAR2 projects, which were previously or recently shortlisted, and the other 4 red were ones which we submitted into HAR2, but were not taken forward for a variety of reasons. Go to the next slide, please. So kind of brief overview of how we do green hydrogen. The way in which we look at it is the source of the green hydrogen is LCHS compliant electricity, but delivered via the grid. Primarily, we do that because while you can do directly connected renewables, we don't feel that you get a high enough load factor in order to produce enough hydrogen enough of the time to give it to an off-taker and justify their expenditure to switch across to hydrogen. So we think having a very kind of high capacity factor in order to to do that is important. We then have the green hydrogen production, so it's through electrolysis, number of typically 5 megawatt blocks. On site, we also have some hydrogen storage as well, which will allow us to do a bit of balancing between the intermittent nature of renewable energy and the intermittent nature of the demand side. And then transportation, we seek to try and do projects which are co-located with the hydrogen off-taker, principally because we haven't yet got a hydrogen transportation and storage network, and therefore it's easier to move molecules of hydrogen than it is, easier to move electrons than it is to move molecules of hydrogen. And in some cases, we're also looking at tanker transport of the hydrogen between our production sites and then into the off-taker facility. So we'll go to the next one. So I'll just go through each of the projects. So Trafford Green Hydrogen, that's an initial 15 megawatt project. It's going to provide 100% of the output from that will go into delivered by tanker into someone in the ceramics industry. And they're currently using some of the work that Andrew's just spoke about to shore up the technical side and then kind of justify the commercial switch across to hydrogen. The site itself is already consented up to 200 megawatts. So largest consented green hydrogen scheme, I think, just in England now rather than the UK. But the site itself has got all grid connections secured, land secured, hydrogen production secured. We've already got planning in place for a hydrogen pipeline and the ability to have a future connection to the gas network. So that is one of our HAR1 projects, is intended to enter into construction this year. Into the next one, please. Barrow Green Hydrogen. So Barrow is one of the largest schemes which secured HAR1 funding. It's a 30 megawatt project which will provide around 100 gigawatt hours of hydrogen into Kimberly-Clark. Kimberly-Clark, who are the tissue manufacturer, that will enable them to switch the majority of their boiler plant from natural gas across to green hydrogen and bring about a reduction in their carbon emissions of in the region of 20 to 25,000 tonnes. And again, that project is intended to enter into construction this year and be delivering hydrogen into that facility from 2027. And then go to the next one, please. And then the Langage scheme, which is down in the southwest. So it's a 10 megawatt scheme, which will produce around 35 gigawatt hours per annum of hydrogen. That hydrogen will be delivered by tanker to two separate off-takers. One of the off-takers is in the asphalt industry. The other off-taker is in the food manufacture industry. An interesting thing in terms of the southwest, the counterfactual fuel rather than being natural gas is kerosene. So in that area, you've got a very weak energy infrastructure, and therefore there are a lot of large industrial facilities currently burning kind of quite CO2 intensive kerosene instead of even natural gas. And again, that's the third project under HAR1, which will get into construction later on this year. We've gone to the next slide. So one of the HAR2 projects, it's Walsall Green Hydrogen. This is a 25 megawatt project, will produce around 100 gigawatt hours of hydrogen, which will go into two off-takers in the ceramic industry. These are difficult to decarbonise industries by virtue of the limited availability of electrification options. And again, we have the land secured, we have the planning in place, we have the shortlisting under HAR2, and now we're currently working on how we put the project together to bring the strike price down as low as we can. And then if we go through to the next project, and then Hartlebury, again, 20 megawatt project, which will be around 80 gigawatt hours of hydrogen, and that will be underpinned by multiple sites within the ceramics industry. Again, difficult to decarbonise industries, and again, HAR2 shortlisting, so we're working our way through to how we get to a reasonable price on that. And if we go to the next one, so I wanted to just kind of bring out a little bit of kind of the challenge of hydrogen and principally how do we reduce the cost. I think we can see from the HAR1 projects, there's an average weighted strike price of about £240, which was felt by government was higher than they expected it to be. I mean, ultimately the price came down to kind of the function of the price of electricity, the equipment and the demand. And if we're looking about how do we kind of bring some of those costs down. So I think in terms of the electricity supply, renewable energy is invariably intermittent and it delivers into an energy market or an electricity market. And there needs to be a kind of trying to find mechanisms whereby we can encourage the use of electricity from renewable sources the majority of time into electrolyzers to produce hydrogen. At the moment, you know, an electricity generator, if they've got a decision between selling to the market at a markup to selling to an electrolyzer, they will sell to the market, and therefore that reduces the amount of electricity and the availability of electricity for electrolyzers. In terms of the equipment supply, you know, kind of CapEx is a key element. The performance in terms of efficiency and degradation is key, and the commercial package around it. Cognizant that a lot of the electrolyzer manufacturers are kind of currently coming out from being very much technology developers and now into technology suppliers, and that scale up of their supply industry will take a little bit of time, but equally to scale up that supply industry there needs to be a large demand for their product. You know, I look back at the example I've used recently around Henry Ford and what he tried to do. You know, when he was doing a Model T Ford, he wasn't looking to do a limited number of cars, he was looking to do 9,000 units in the first year. The HAR2 projects will support around 35 to 40 units. So clearly, if we want to start reducing some of the equipment supply costs, we need to be able to increase the demand for hydrogen, which in turn increases the demand for electrolyzers. The final bit around the demand, you know, when we're looking at individual projects, we do need to manage quite a lot of demand variability. So while a lot of industrial sectors and even other sectors that use hydrogen would consider themselves to be a baseload demand, it is not always steady state and can be subject to fluctuations related to demand for the end product, and equally fluctuations to do with what happens within their process. So in the paper manufacture process, there can be issues where you get a paper break, steam demand drops off, and then it takes a little bit of time to come back up. And that's the kind of demand variability that we need to supply or account for. And then equally, we need to manage those supply interruptions. So if we have a case where we are unable to provide hydrogen, either by virtue of the electricity market conditions or maintenance on the actual hydrogen production facility itself, what does the off-taker do in order to manage that supply interruption? And while a lot of them can switch to natural gas, and albeit that has a slightly higher cost associated with carbon credits and non-commodity costs, it doesn't help to justify that capex. So if a supplier, or sorry, an off-taker switches across on the basis that they're going to switch 100 gigawatt hours of hydrogen, and ultimately they only get 50 gigawatt hours of hydrogen, they've missed out on 50 gigawatt hours of savings to justify that capex. So we need to be able to very much manage those supply interruptions. And I think what I would say on that, linking in a little bit to the previous two presentations, you know, a lot of the work has been done now around technically how do we use hydrogen, and technically how do we produce hydrogen. The key bit now is technically commercially how do we manage the interface between the two parties. And the commercially first of a kind is a challenge in order to provide the surety of hydrogen supply to justify the off-taker to switch cost of hydrogen, combined with the surety of demand to justify the investment in the production facility. And then we've gone to the next slide. And then, yeah, that was everything I had to say. So happy to take any questions, either through the chat or directly.
No, thank you very much, Eric. Yeah, no, really, really interesting. And as you say, yeah, it's nice to see how it kind of all goes full circle amongst the talks there. So from the ceramics demonstrating the need, showing that it's technically feasible, and now to kind of yourselves actually supplying some of those sites. That's really great to see. You would have missed at the start, kind of just did a brief recap on some of the announcements earlier this week on the industrial strategy. I just wonder if you have any thoughts with regards the removal of the climate change levy on electricity for electrolysis and some of the other announcements. Is that going to really help your costs?
Sorry, was that to me, Aaron?
It was Eric.
I missed that completely.
The announcements earlier this week with the industrial strategy, it alludes to kind of helping to reduce electric costs for electrolyzers through kind of removal of the climate change levy and a few other bits and pieces. Do you think that's going to really help drive down costs, or is that a small change in the grand scheme of things?
I think it's a start, but I think it's still got some way to go. So, I mean, some of the climate change levy costs were actually excluded from HAR1. So it was an excluded cost. So the prices we see on HAR1 just taking the climate change levy out in the absence of anything else doesn't actually move the needle on that cost, because it was, you know, it was already excluded, but it is helpful. I mean, I think there are a kind of wider package of things that need to happen on the electricity side in order to kind of drive further reductions in that cost. And I kind of touched a little bit upon, you know, electricity generators would have a preference for selling their electricity into the market if they get a higher price, and equally electricity producers have kind of very little disincentive in terms of when the price is low to divert it into more valuable means uses of that electricity, or even the curtailment issue. And I think that it'll be interesting to see. I think definitely bringing the electricity price down is going to be of benefit, but I think that should happen across the board, regardless of whether you're using electrification directly for decarbonisation or whether you're using electrification indirectly by producing hydrogen and then using that for decarbonisation. I think the electricity prices need to come down across the board, and I think it needs, you know, there's probably a number of different things that need to happen in parallel for that to take place. I don't think there's any one singular like silver bullet that kind of magics all the problems away.
Sure. Yeah, no, that makes sense. Thanks very much. Conscious we have run kind of right to the end there. Are there any final questions for Eric or for any of our other speakers today? If not, then that just leaves me to say a big thank you to everyone on the call today, to all our speakers. Thank you for your time and for GemCirc to pulling it all together. I think we will take some learnings from the timings, give ourselves a bit more time next time. And obviously a lot of people in the chat there, it seems like there's a real interest in kind of engaging with each other and kind of sharing emails and whatnot. We'll take that away and have a little think. It could be that we set up maybe like a LinkedIn group or something similar as a way to kind of carry on that engagement. So yeah, we will get back to you on that. If anyone would like to speak at the next session, then please do get in touch. It doesn't have to be a full, 15-minute or more presentation. Even if it's just a small update from your organization, we'd be happy to kind of hear from you. And yeah, otherwise, thank you very much all for your time, and I will see you on the next session.
Thank you.
Bye.